Introduced in 1792, gasification is a process that converts coal and other carbon-based materials into synthesis gas, or syngas, which is a mixture of carbon monoxide and hydrogen. Once processed, coal gas can be used as a versatile ultra-clean fuel for generating electricity, manufacturing chemicals, and as a fuel source for vehicles in the transportation industry. In the 19th and early 20th centuries, coal gas was used to illuminate street lamps, warm homes and businesses, and power industrial steam engines. By the 1960s, coal gas was replaced by oil and natural gas as our nation's primary suppliers of power, heat, and light. Modern gasification technologies, diminishing supplies of oil and natural gas, and the rising cost of these fuels have renewed interest in producing coal syngas as a desirable alternative. In the modern gasification process, coal is fed into a gasifier and exposed to steam and oxygen at high temperatures and moderate pressure. Under these conditions, a series of chemical reactions occur that break the coal down into its base components: hydrogen, carbon monoxide, sulfur, and mineral impurities. The syngas is then cleaned to remove these impurities, which can be used to produce fertilizers, construction, and road building materials. Coal syngas is used in a modern turbine power plant called an Integrated Gasification Combined Cycle, or IGCC power plant, which is today's environmentally preferred method for producing electricity and manufacturing chemicals. IGCC gasification is the primary technology component of FutureGen, the Department of Energy's zero-emissions power plant. Coal syngas can also be used to refine natural gas for home heating and industrial use, to produce hydrogen and other transportation fuels, and as the base component in chemical processes that create a multitude of everyday products, from plastics, solvents, and adhesives, to cosmetics, artificial sweeteners, and pharmaceuticals.
There is another, much cleaner way to create electricity from coal. It's called Integrated Gasification Combined Cycle, or IGCC. Instead of burning coal directly, IGCC first converts coal into a gas. This synthetic gas, or syngas, can be thoroughly cleaned, removing a large percentage of the pollutants that would otherwise end up in the air. The syngas is then burned in a state-of-the-art turbine generator. Excess heat from both the gasification process and the gas turbine is converted into steam and used to power a steam turbine generator, producing even more electricity. Most important, given our concern for global warming, IGCC technology presents the ability to capture and store carbon dioxide, to sequester it, instead of releasing it into the atmosphere. Some of the biggest names in power plant engineering are promoting IGCC. Imagine how effectively we could reduce carbon emissions all around the world by embracing this technology.
The process begins with coal entering the system, mixed with water, creating a slurry that has the consistency of heavy oil. The slurry is injected into the gasifier along with oxygen, where it is heated to very high temperatures to produce synthesis gas, or syngas. The hot syngas is fed into the radiant syngas cooler. Heat from the gas is transferred to the high-pressure steam system for integration into the steam power production cycle of the plant. The syngas moves to the low-temperature gas cooling system, where more heat is extracted for useful work. The syngas passes through an activated carbon bed that removes mercury. Once it leaves this area, there are almost undetectable amounts of mercury. It then continues to the acid gas removal process, where hydrogen sulfide is separated from the syngas and later converted into elemental sulfur that can be used in chemical processing.